Okay, good morning. Okay, we are moving to the last chapter, chapter 9, partial differential equations. Okay, and before, um, let's have a introduction of what is a partial differential equation. Okay, short form PDE. Okay, is an equation involving you have the partial derivative. Okay, and how do you get the partial derivative? If you have a function of several variable, let's say you have a function of, now you have, in this example here, you have function of, I think got problem. Okay, this should be y. Okay, because you have x, y. Okay, I'm sorry. So this is y. This is y. Okay, the notes you can get it from author. Okay, you have function of more than one variable. For example, here u is a function of x and y. Hence, you can get the partial derivative. Okay, del u del x. Okay, or you can get first derivative del u del y. And then you may get the second derivative. Okay, as here, this is second derivative del 2u del x2, or you can get the mixed derivative del 2u del x del y. Okay, and then this is del 2u del y2, or del u del x first derivative del u del y. So PDE is an equation consists of the function of several variable, like here you have the u x y and its partial derivative, where a b c d e f here are constant. So a b c d e f g here are constant of function of x and y only. And then we are going to learn four types. Is it? Yeah. Okay, you have four types of PDE. You have the heat, wave, Laplace, and Poisson equation. Okay, just now this one, this is y. This one, this is this is y. This is y. And then the first type is heat equation, where the coefficient of b squared minus 4ac equal to 0. Okay, I will get and we call this category as a parabolic equation. Okay, example is a heat equation, where it's given by the heat equation is here del 2u, where for heat equation u is a function of x and t. So mean the t is equivalent to the y in the general second order differential equation given here. This one equal to g here. Okay, and how you know b squared minus 4ac equal to 0? Okay, you have del 2u, del x2 minus 1 over c squared del u del t equal to 0. Okay, you may tally, back, here. There's a mouse. Okay, here. This one. This is actually in here. This one is a. I mean, in this case, a is 1, because you tally this one with here. And then, and then del u del t, you can tally it with the del u del y. Because for heat equation, y is actually the t. So mean a is 1. You don't have b and c. That's why b and c is 0. That's why b squared minus 4ac, you have 0 here. That's why for heat equation, it is where the b squared minus 4ac equal to 0, and it's called, this category is parabolic. For example, is a heat equation given by del 2u del x2 minus 1 over c squared del u del t equal to 0. Second type is where b squared minus 4ac positive, and this is a hyperbolic category. Example is a wave equation. The difference with heat and wave is actually, for wave, the del u del t, this is up to second order. Hence, okay, if you compare del 2u del x squared, so mean a in this case, a is equal to 1. T, okay, del 2u del t squared you compare with here, because for heat and wave, y is actually the variable time t. So means, okay, in here, in this case, so for wave, the coefficient c is actually negative 1 over c squared. Okay, we don't have the b, so mean b is 0. In this case, b 0, c 0. That's why b squared minus 4ac have 0. Okay, then when you plug in, b is 0, b is 0, that's why b squared minus 4ac for wave equation is actually, okay, 0 minus 4 times ac, you have positive, because minus, okay, with negative you get positive here. So this is wave equation, okay, it's actually belong to b squared minus 4ac positive, and is a hyperbolic equation. And okay, example is a wave equations here. And we have got the third case where b squared minus 4ac, b squared minus 4ac less than 0. Okay, you have two equations here, which is Laplace equation and Poisson equation. Laplace, the right hand side is equal to 0. Poisson, right hand side, okay, is a function of fxy. And okay, you see left hand side, both Laplace and Poisson equation are same. Okay, when you compare Laplace equation with the general, okay, second order PDE, the given PDE here, a is 1, because you compare here. Okay, a with del 2u del, okay, del 2u, okay, del x2, a is 1. Then you get here this equation, del 2u del y2, compare with the Laplace and Poisson equation. So mean c is here 1. Okay, don't have the b, that's why b is 0. b is 0. Okay, that's why 0 squared minus 4ac, you have negative. That's why Laplace and Poisson equation, okay, where the b squared minus 4ac less than 0 and is under the category elliptic. So for the second order, okay, PDE equation, we are going to, okay, learn these 4 type: heat, wave, Laplace, and Poisson equation. Okay, so far any question? We haven't go into the the detail. Okay, so just introduction. The PEDE that you're going to learn, you got heat, wave, Laplace, and Poisson equations. Okay, if no, okay, we move to, okay, how to solve the PDE. We are going to solve the PDE similar to ODE using finite difference method. Okay, where if the heat and wave, okay, the horizontal axis is x, vertical axis represented by t, heat and wave. Poisson and Laplace, okay, horizontal is variable x, vertical is a variable y. Okay, and then, okay, you have the function of uxt, uxt. Okay, so x is going to discretize using I variable, so it's xi. T is discretize using the j variable, so uxitj, okay, can be simplified as u I subscript, u subscript I comma j, here uij. So mean, okay, how do we, okay, those who would like to come late, next time I'll let you enroll at the end of the class, because it's quite disturbing. So for the ukxitj, simplify as uij mean the x, okay, variable x here, you are going to discretize, okay, start from, this is x naught, x1, x2, x, okay, up to xi plus 1. Okay, where the delta x is equal to h is actually xi plus 1 minus xi. Okay, variable t, okay, from T0, T1, T2 up to Tj plus 1, where the delta T is actually equal to K equal to Tj minus 1 minus Tj. Okay, this is K. The increment of delta X is H. So for example, this point is Xi, Ti, so this is U11, X2, Ti, U21. Okay, and then here xi t2 u12. So general xi tj. So actually the solution is at this node here, at the nodes. Okay, and then for simplification, um I'm not going to solve like this. I will take the whole for example u11, I will put the result into this cell. U21 I put in the second cell here, so that also we can easy to to put the solution in in Microsoft Excel. Okay, if you like, you can actually point out the solution is actually at here, mean xit1. Okay, but easy, I will just build up the table form. Mean this cell represent is actually solution of xi. This cell is solution for I will put the whole solution u11 in this cell. So this is u21. Okay, and this one is u22. Okay, the person who like to late is always late. Okay, next round. Okay, if you're late, then you just watch back video, because it's very disturbing. Okay, I have been telling you several times. So now we are going to look at the parabolic equation. Okay, for example, it's a heat equations. Okay, so we have the heat equation is actually described by just now is del u del T equal to you see back this one, just bring back here del 2u del x2 minus 1 over c squared del u del T equal to 0. Okay, and we will put up to this form del u del T. Okay, you make del u del T as a expression. So mean you c squared here, you eliminate by multiply with c squared, and then this one bring to the other side. That's why you got del u del T equal to c squared del 2u del x2. Mean here you multiply by c squared, so this one no more c squared, so minus. So it become minus del u del T to the other side. You got del u del T equal to c squared del 2u del x2. So here, so the heat equation del u del T equal to c squared del 2u del x2. So you notice del u del T, mean the time derivative is only first derivative. Space derivative is up to the second order, del 2u del x2, where the u is a function of x and t. And heat equation, let's say we consider we have a one-dimensional uniformly heated rod with inertia example ux0, because you have the uxt, uxt. So inertia with inertia conditions, with inertia conditions, ux0 equal to hx. Mean the inertia example temperature. This is initial temperature. You have a rod which is heated, so you got the initial temperature. Initial temperature is when T equal to 0. That's why U bracket X comma 0 equal to Hx. So this is the initial temperature, and the rod is actually heated rod is positions mean put from in the interval X up to, and the rod with the length L. And then the temperature of the rod at its left end is given by U0T equal to sorry, it's not U0T is FT, the left boundary condition. Left because the rod is put from x equal to 0 up to x equal to L. That's why U0T equal to function of T. This is the temperature of the rod at its left end. Temperature of the rod at its right end is ULT. ULT equal to GT. And then the temperature distribution of the rod uxt at any position x and any instant t can be described by the heat equation. So the U here, uxt is actually temperature distribution of the heated rod at any position x, any time t. Okay, this one uxt here describe the temperature distribution. Okay, so we have here del del tu, okay, uxt, x is discretized using xi, t is discretized using tj. So that's why equal to c squared del 2 del x2 u xi tj. Okay, can be simplified as uij, mean as as described just now. Okay, you have the uxt, x is discretized as the xi, t is discretized as tj, can be simplified as u subscript ij. That's why the heat equation initially you have del u del t equal to c squared del 2u del x2. Okay, can be simplified as del u I subscript u I comma j, okay, over del t equal to c squared del 2u ij, okay, over the del x2. And then to solve this heat equation is actually we would like to know the temperature of the heated rod at certain position x at certain time t. And then to solve this we use the finite difference that you learn in numerical differentiation in chapter 5. And for the time derivative we use actually 2-point forward, so they call it as forward time. Okay, the second derivative for the space is used 3-point centra, so short form they call forward times centra space. So this is actually 2-point forward. Okay, you may draw, let's say, the grids. Okay, let's say this point is uij. Okay, center is I, right point is I plus 1, left point is I minus 1. Okay, and then uij, this is a level j. Okay, top level is level j plus 1. Okay, so for del u, del uij del t, differentiate respect to time t. T is vertical, using 2-point forward, so mean standing at uij, this point xi tj, so this point refer to uij. So using 2-point forward, you need the point ahead, which is uij plus 1. So that's why for the time derivative, you have uij plus 1 minus uij divided by k. Cos here, delta t equal to k. That's why for the time derivative, del uij del t is actually uij plus 1 minus uij divided by k. Then equals c squared. Okay, this is a differentiate respect to x. Okay, for second derivative using 3-point centra. Okay, recall back using 3-point centra. Mean the second derivative that you learn in ODE. Remember ODE y double prime. Okay, you have y I. Okay, y minus 1 minus 2y I plus y I plus 1 divided by h squared. Here, for second derivative respect to x, x is actually discretized using variable I. So mean you have here center point, you're standing at the uij. Okay, the point ahead you have u I plus 1 j. Okay, the left point, because you're standing at the same level j, okay, left point is u I minus 1 j. Okay, and then you tally back with the y double prime. Okay, and increment of x is actually h. So that's why you have here left point ui minus 1j minus 2uij plus ui plus 1j divided by h squared. mean, okay, this is 2 point forward, differentiate respect to time t. T is vertical. So your molecule, you have to take, okay, uij, ahead is ui, because you are standing at I, time is vertical. So I, okay, there's no chain, only j, okay, from j jump to j plus 1. That's why, okay, del uij del t is uij plus 1 minus uij divided by k. For space is horizontal. So center is uij, right is ui plus 1j, left is ui minus 1j. You tally back with this formula, y double prime, okay, or the second derivative in chapter 5. So you obtain this formula here. And then, okay, later on we are going to solve for this term uij plus 1, uij plus 1. That's why the k here you bring to here. So mean you will get okay, you will get ui j plus 1, so minus uij, where you will k c squared over h squared, multiply the right hand side, which is ui minus 1j minus 2uij plus ui plus 1j. Okay, later on we are going to solve uij plus 1. That's why the minus uij, okay, it become and from here you have uij plus 1 equal to, where the kc squared over h squared, okay, denote as r. So you have r ui minus 1j minus 2 uij plus ui plus 1j plus, from here this term minus uij bring to right hand side become plus uij. So when you expand in, you have r ui minus 1j. So this one minus 2r collect with 1 time of uij. So uij total you have 1 minus 2r. And then when you expand, okay, ui plus 1j, the coefficient is r. Okay, that's why after you substitute the time derivative using 2 point, okay, 2 point forward difference, the space derivative, okay, using 3 point centra, simplify, you will arrive at the uij plus 1 equal to r ui minus 1j plus 1 minus 2r uij plus r ui plus 1j, where the r is actually kc squared over h squared. Okay, and then from here it will be easy if you represent using the molecule, because it's easier to, okay, remember the graphic rather than the equation. Okay, if you notice here, uij plus 1 mean level j plus 1, okay, mean is top level. You have 1 time uij plus 1 equal to, okay, you see here, level j, level j, level j. Okay, I minus 1 is a left cell. Okay, uij is a center cell. I plus 1 is the right cell. So that's why this one is level, here is actually level j. This one is actually targeted cell is actually level j plus 1. That's why, okay, when we derive the formula is from the, okay, the molecule here. So left cell, the coefficient is actually r time. So r time of ui minus 1j. Okay, center bottom cell, the coefficient is 1 minus 2r. 1 minus 2r time of uij. Okay, the right bottom cell, the coefficient is r time of ui plus 1j. So with this molecule, okay, so mean we know the initial condition, you know the left boundary, right boundary, then we can solve, okay, all that targeted cell up to the desired, okay, level that you need it. So up to now, okay, do you have any question before we go to the specific example?
No, Rate.
Okay, thank you. If no, we look at the example. Okay, given the heat equation del U del T equal to del 2U del X2, where the X from 0 to 1, and then the T greater than 0 with the boundary condition U0T equal to U1T equal to 1. The initial condition is Ux0 equal to exponent x1 minus x for, okay, the x from 0 to 1. Find ux 0.01 and ux 0.02 using explicit finite difference method for x equal to 0.2 to x equal to 0.8 with h equal to delta x equal to 0.2. Okay, first of all, okay, you can draw the grids, okay, where we solve x from 0 to 1. Increment is 0.2, so mean h is 0.2. Okay, t, okay, this is t. T from 0 to 0.01, 0.02 means k is actually delta t equal to 0.02. Okay, then first step, you may draw the grids. Okay, the grids here. x0, increment 0.2, 0.4, 0.6, 0.8 up to 1. T from 0, 0.01, 0.02. Okay, as I said, okay, easy I put into the table form, but actually this solution is at this node. I mean the one here stand for here. Okay, here we put at the center, okay, center alignment so that we easy to put into the table form. Okay, but the the O, okay, means suppose the solution is here. Okay, 0 is here. Okay, and then this one is 1. So this is 0.2 with 0.01. Mean this value, sorry, I will erase it. And suppose okay, the value, okay, this value is here, this one is here, this one here, this one here, this one here. Okay, okay, never mind. Where is it? Yeah, because it's like this. 0.2 is here, 0.4 is here, 0.6 is here, 0.8 is here, 0.1 is here. Okay, and this is from the initial condition ux0 equal to exponent x1 minus x. Okay, suppose okay, here you can quickly tabulate this one using your table menu. Okay, on. Okay, the fx, okay, is exponent x1 minus x. Gx, we let it 0. Okay, the x from 0 up to 1. So starting 0, 1, step is 0 0.2. 2. So you have here 1. 1 is actually we should point the arrow to here. So easy, I will put the representation of when t0, x0 in the center of the cell. But suppose this one is look at this point. Mean 1.1735 is actually at here, this solution. Mean at this, okay, at this node. When okay, when your t0 x.2 is actually refer at this location. Mean the location is here, this one. So but okay, you have to put the arrow, and then to simplify we just put at the center of the cell. Mean this value is referred like here. And then you can tabulate the initial condition is happen when t0 using the table menu. So you have 1.1735, I just put to the second cell. Later on 1.2712, 1.2712, okay, 1.17351. Okay, up to here, okay, is it clear? Mean the correct solution actually is at the nodes there. But I put at the middle of the cell, okay, of the table so that easy. So that's why you see I change here this one to center. If this one center, center, and center, so that's why everything put into the center of the table here. Okay, after that you have the U0t. U0t mean x0, x0. So x0 is here. U0t equal to 1. That's why all the left boundary are 1. U1t equal to 1. Mean after you draw the grid, okay, x 0, 0.2, 0.4, 0.6, 0.81, t 0, 0.01, 0.02. Then you put in the initial condition, you put in the boundary condition. This may be your step. Okay, step 1 you draw the grid. Later on step 2 you can put in the initial condition. Step 3 you put in the boundary condition. Okay, after that, okay, you can, given the h is actually 0.2, c squared is actually from here. Yeah, coefficient for del 2u, del x2 represent the c squared. So c squared in this case is 1. K here, k is a delta t is 0.01. Then you calculate r, which is kc squared over h squared. You get here 0.25. And then you can calculate 1 minus 2r. You will get 0.5. Then this is a general molecule for the explicit heat equation. Okay, explicit because, okay, your targeted cell, you have only one cell, okay, and then you know the this is initial condition, you know the boundary condition. So as what I highlighted with this, okay, the blue color here. Okay, to know this cell, this is what we call the targeted top cell is equal to r time of your left bottom cell plus 1 minus 2r time of your center bottom cell plus r time of your, okay, right bottom cell. Okay, and then, okay, the r, that's why you need to know the r is 0.25. So you put into the specific molecule 0.25. Okay, right bottom coefficient is 0.25. 1 minus 2r, you get 0.5. Okay, and then you can easily know the, okay, the value here. Okay, first of all we look at here the highlighted, okay, blue color targeted cell here. Okay, what you need to do, where's my calculator? Here. Then mode number 1, you can just key in the formula 0.25 alpha A plus 0.5 alpha B plus 0.25 alpha C. Calculate where the ABC is actually, I represent the ABC is actually left bottom cell, center bottom cell, right bottom cell. Mean the targeted cell here is is equal to R, which is 0.25 time of your left bottom which is 1. Okay, center bottom which is B is 1.1735. C is actually 1.2712. Okay, so mean what I'm going to do is actually I calculate. They're asking for A. You key in the value for left bottom cell, which is 1. B, 1.1735. C, 1.2712. Then you get 1.1546 here, the first one. Okay, up to, okay, the first value here, make sure you understand. Because later on, the pattern is repeated, mean the molecule, okay, from here, you're going to move to here. Then your A, B, C chain, okay, move to one column to the right-hand side. Okay, up to here, any questions? Any question or
No,
not?
okay.
No, can get it.
Doktor,
Yes.
Can or not?
boleh tak doktor ulangkan semula yang dalam calculator tu?
Okay, your formula, this one, okay, the molecule here, is it okay? Can you get this? This is general molecule for the, okay, explicit heat equation. And then you calculate R is KC squared over H squared. You get 0.25. So 1 minus 2R, okay, you have 0.5. So you put this one to the specific molecule. And then you observe this molecule. You apply the molecule here. You want to find this one, the target, okay, targeted top cell that you want to find, okay, is equal to 0.25 time of, okay, suppose, okay, the traditional way is actually you want to find this one, okay, I start, okay, if I discretize I, the traditional way you need to write a lot, okay, so right for you this I, X discretize using I is 0, 1, 2, 3, 4, 5. Okay, T using J is actually, this is 0, 1, 2. Okay, this cell is actually the Uij. So this cell is actually U1, 1. Okay, so you want to know this cell U11. So mean your I is 1, J is 0. Okay, mean you let I is 0. Okay, I is 0. Is I is 1. Okay, I is 1, J is 0. Into here, you will get U1, 1. Here, this one, I is 1, J is 1, U11. U11, if we put back to this molecule, R, okay, R that we obtain is 0.25, means 0.25 U, okay, I is 1, so U, 1 minus 1, so U0, 0 plus 0.5 U10 plus 0.25 U20. Okay, mean U11 is actually 0.25 times this cell is actually, this is U00. This cell is actually U10. This is U20. If you put, okay, if you put the I is 1, J is 0 to the, okay, molecule here, you get U11 equal to 0.25 U00 because I is 1, J is 0. U00, 0.5 time of, okay, U10 here, okay, U20 is here. Then manually, if traditional way, then you have to put up here 0.25 you multiply. Okay, U00, the value here is 1. And then 0.5. Okay, U10, the value is 1.1735 plus 0.25 times 1.2712. Manually, you will calculate like this. Then you'll get 1.1546. Okay, manually, okay, to get the first value 1.1546, what you calculate, you see 0.25, A you represent by 1, B you represent by what? 1.1735, C you represent 1.2712. Mean manually you calculate 0.25 multiply 1 plus 0.5 multiply 1.1735 plus 0.25 multiply 1.2712. So you get here 1.1546. Okay, and then what I represent is actually U00. I represent this as a A. In the left cell, Uij I represent using B, Ui plus 1 I represent using C, where this is A, B, C. Because later on, when you want to calculate U2, okay, this is X is 2. When you want to calculate U21, U21, yeah, no place to write. Okay, you want to calculate U21, I just change color because no space to write. Okay, when you want to calculate U21, it's actually the I become 2. Mean you change I become 2. I become 2. So U21. Okay. So this will become when when you increase I by 1, so this become 1, this become 2, this become 3. So the value, because you already changed u, from u1 0, u2 0, u3 0. So the value from 1, 1.1735, 1.2712, move one column to right hand side. This value become 1.1735. This one become 1.2712. This value become says 1.2712 because they are symmetric. So you see the pattern is actually repeated. When you calculate U11 to U21, it's actually look like you move your molecule. Okay, now you target at here. So your left is here, center is here, right is here. So here. So mean when you target at U21, your A is this value, B is here, C is here. Okay, so you can just use back your calculator. Mean instead of you manually you write one by one here, time consuming. Later you said not enough time to solve. So that's why you represent using formula 0.25A plus 0.5B plus 0.25C. Then you calculate. So now A, just now, initially from 1, we'll move to one column to right side. So A now become 1.1735. Okay, B from here, move to, initially A, B, C here. So A now start from 1.1735, so B center will be 1.2712. Okay, C become 1.2712. Then you get 1.2468. Okay, do you see the numerical method is actually when the first one you understand the pattern is repeated. That's why I said if you perform it in Excel even easier. Okay, here 1, 2, 3, 4, 5, 6. This one 6 column. That's why I cannot use a spreadsheet menu. Unless it's 5 column, then you can use a spreadsheet menu. This one more than 5 cannot. But you can perform it in Excel is much easier. Excel, you just make sure you key in the first formula U11 correct. Okay, you drag to complete your level 1, and then you select the whole level 1, you drag up to complete your level 2. So if you use calculator, if you use a traditional way, then you write like this one. You write general molecule, right here U, and then put up the value for the U. So this is U21. If U31 means I now change to 3. And then you write again. So it's time consuming to write. So mean later on, green. So I become 3. This one become 3. So 3, 1 become 2, 2 become 3, 3 become 4. So mean the value is actually now U31, the green color, depend on the left will be here, this one. Okay, the rest maybe you erase, otherwise you're very confused. Okay, focus now the green. Okay. Like this. Okay, this is U31. This cell is U31, depend on, this is U20. This is U30. This is U40. So you see U31 depend on U20. Okay, U20, U30, U40. And then put in the value for U20 here. 1.2712, 1.2712, 1.1735. Okay, if you like to write manually, then you write it, no problem. If you got a lot of time, if you can write quickly, no problem. But the pattern is actually repeated. That's why I will prefer is either at least you put using the formula 0.25A plus 0.5B plus 0.25C. Then you just press your calculator quickly. You just fill in your level 1, level 2. I mean here. So now U31 calculate again, because the pattern is repeated. Left now is 1.2712. Center, okay, because they are the initial condition is symmetric, so the center B is, okay, if the same, you just press down. C now 1.1735. So you get 1.2468 U31. Okay, and then so you repeat the process until you complete all the solution that needed until you x where the t is 0.02, mean you got 1 2 3 4 4 5 6 8, at least x value to be solved there. So mean now you complete this one. It may erase. Why so many messy? Okay, so you want to get this cell. Okay, now I focus here. This one, this is actually depend. Look at the molecule. Left is here, center is here, right is here. So mean A, B, C. So calculate again. A, okay, because the A same value, we just press down. B is 1.1735. C is 1. So you get 1.1546. So you complete level 1. Okay, if you complete level 1, now we want to calculate level 2. Okay, level 2, so the same process, you just move the molecule up. You want to solve this one, this value. Okay, left is here. Mean this is A. So this value is B. This value is C. Then you calculate again. A is your left bottom, which is 1. B is the center bottom cell, which is 1.1546. C is the right bottom cell, 1.2468. So you get 1.139. Okay, after that, then later on you target here, target at here. So the left, which is the A, center bottom, which is the value of B, right bottom, which is the value of C. So repeat the calculation. Calculate again. Now A is here, 1.1546. B is 1.2468. C is 1.2468. You get 1.2238. Okay, and then I erase it. Then you move to here to calculate this one. So this is A, this is B, this is C. Then you can get this cell. Okay, so calculate. A is 1.2468. B also, B same. Then C 1.1546. Then get 1.2238. Okay, then erase it. Okay, the last value. Okay, the last value here, this value. Okay, the left. Okay, the left from what you target, center, bottom, right bottom. So this is the value of A, B, C. Okay, then you calculate. A is 1.2468 because symmetric, so you just press down. Okay, B is 1.1546, C is 1. Okay, 1.139. Okay, you see the value is symmetric because the initial condition symmetric, and the molecule here actually the symmetrics are okay to left bottom, right bottom symmetrics. Okay, this is using the calculator. So far, any question?
No, doctor.
Doctor, is the C square always 1?
Depend on the question. C squared in this example is 1.
Oh,
Means C squared is a coefficient for del 2u, del x2. Depend on the question.
okay, doctor.
Okay, and then we answer. Okay, first for a while we try to solve using, you can see Microsoft Excel is easier and faster. Okay, I copy. Okay, you have here del u del t equal to del 2u del x, okay, del x squared, so mean the c squared is actually 1. Okay, and this question h is 0.2, k is 0.01. Then you can calculate the r is actually can equal r is kc squared over h squared. So it's k times c squared divided by h squared. So r is 0.25. Put up r is actually kc squared over h squared. Okay, and then you need to calculate 1 minus 2r is actually 1 minus 2 times r, you get 0.5. Okay, and then your general molecule, you have actually one targeted cell equal to the r is 0.25. Okay, and then the 1 minus 2r is 0.5, r is 0.25. Okay, so in Excel I just draw the molecule this way. One targeted cell equal to 0.25, okay, of the left bottom plus 0.5 time of center bottom plus 0.25 time of the right bottom. Okay, maybe I put left bottom. This is a center bottom. This is a right bottom. Okay, this is one time of the target. Target is the cell that you want to solve. Okay, and then you may draw the grids in Excel. Okay, again, okay, up to 0.02, 0.01. So this is 0. X from 0.2. Okay, up to 1. Okay, and you can put out the initial condition is here. Initial condition. This is initial condition. Okay, let me put out the grids here. Center. Okay, initial condition given is, you see, initial condition ux 0. This is t0. So initial condition is a bottom level. The bottom, the mean when t0, the whole mean level 0. Here, okay, you may put out is exponent exp, exponent x bottom multiply 1 minus x, x here, close. then you copy it. Okay, this one is didn't round anything. If you want to round, you can round it. So you can tally with the calculation using manual, using the scientific calculator with 4 decimal place. Yeah. Okay, and then the first step, you may draw the grids. Later on, second step, put out the initial condition. Third step, put your boundary condition. Okay, boundary condition given is this. Put out here. Okay. Okay. U0t means when x 0, u is 1. Okay, this one I hope you can read it, okay, understand it. This one means x 0, u equal to 1. This means x equal 1, u equal to 1. Okay, this one means exactly, okay, this is t0. U is exponent x1 minus x. Okay, so the boundary means when x0 is a whole, okay, left, so left side, okay, this is 1, this is 1. Okay, right side, when x1, this is 1, this is 1. So now you have only 8 value to be filled in. Okay, to solve this cell, so this is what you target like this one, right here. So this cell is actually, if you refer to the value here, then you need to make it constant. Okay, so to you, if you not make constant, later on the value will be run, because the R is actually 0.25 is a constant value. So if you refer to the molecule, then you make sure constant it by put up the dollar front and back. Otherwise, you put up 0.25 multiply your left bottom cell. Okay, 0. This is R multiply left bottom plus, okay, this is 1 minus 2R. Okay, make it constant, or else you type in 0.5. Okay, multiply this one plus, okay, this cell, okay, dollar, so multiply the right bottom. Okay, and then you just copy it, then you copy it up. This one is without round. If you want to round to 4, so 139, you see the last one, 139, 139, 2238, 2238, 2238. So this is using Microsoft Excel, much faster. Just key in the U11 correctly, copy it to the right, copy it up. So you can copy it as many level that you want. Okay, so any questions here?
No, doctor.
Okay, if not, we second example similarly. Okay, the second example, okay, so now del u del t equal to 4 for del 2u del x2. So mean the c squared now is 4. Okay, solve from, I think got some, okay, x from 0 to 2, t greater than 0. Okay, boundary condition, oh, x up to 2. So this one should be 2. U0t equal to t exponent, okay, exponent negative t, so this should be u2t. Okay, this value, this one should be, okay, typo, this one should be u2t equal to t. This is an initial condition where x 0 to 1, the function is x. When x from 1 to 2, the function is 2 minus x. Okay, against find u x 0.01 and ux 0.02 using explicit finite different method for x 0.5, 1.5 up to 1.5 with h equal to delta x equal to 0.5. Okay, so similarly, first step, you draw the grids here. So x 0, 0.5, 1, 1.5, 2. Okay, this is actually left side t. T from 0, 0.01, 0.02. Okay, initial condition is here, ux 0. Initial condition happen when t equal to 0. Okay, and then initial condition, you got two different function, x 0 to 1. Your initial, okay, the u is depend on the value of x. That's why 0 to 1. Okay, for 0 to 1, u is depend on x value. That's why 0 to 1, the u, when t 0, this is 0, this is 0.5, this is 1. Okay, later on, when t 0 and x from 1 to 2, 1 to 2, okay, the u is 2 minus, okay, 2 minus x. So when x is 1, 2 minus 1, 1. That's why, okay, these two actually intercept same value. So when x is 1.5, 1.5, 2 minus 1.5, you get 0.5. So when x is 2, 2 minus 2, you get 0. So this is the initial condition at the level 0. Level 0, t equal to 0.1, this is level 1. T equal to 0.02 is level 2. Okay, boundary condition, u0t. So mean this is x0. So the left, or the left, okay, border, left border is given by t exponent negative t. Okay, and the right border, okay, right border is u1. This is 2. U2t is equal to t. So t0 is 0, t 0.01. That's why equal back to okay. This one is t here. Sorry, think labeled wrongly. Yeah. Why cannot to erase this one? Cannot. Okay, suppose this one. Yo, what happened? U1t is here. Okay, you see the yellow. This is a left boundary, right boundary. This is a initial condition. So you have to determine actually inner is 1, 2, 3, 4, 5, 6, 6 cell only using the general molecule for this is explicit heat explicit scheme for solving the heat equation. You have a targeted cell is 1 targeted cell equal to R time of your left bottom cell plus 1 minus 2R center bottom plus R time of the right bottom. So again, given H is 0.5, C squared from the heat equation, coefficient for delta U del X squared is 4. K is a delta T, which is 0.01. You calculate the R is K, 0.01. Okay, let me calculate it. Okay, means R is 0.01, C squared is 4, H is 0.5, and then you square it, you get 0.16. Okay, so 1 minus 2R is 1 minus 2 times the answer 0.68. Okay, so that's why this is general molecule. This is a specific molecule. For example 2, R is 0.16. 1 minus 2R is 0.68. Okay, R is 0.16. Okay, means you using this specific molecule, apply into the grids, then you can know this 6 inner value here. Okay, so this is, you can represent A, B, C. Mean Ui minus 1j is a left bottom cell, Uij is a center bottom cell, Ui plus 1j is a right bottom cell. We represent using A, B, C in your calculator. So mean now if you want to solve this cell, it depends. A is 0, B is 0.5, C is 1. Okay, provided you put into the formula, okay, 0.16a plus 0.68b plus 0.16c in your calculator. Okay, so we will put 0.16, okay, a plus 0.68b plus 0.16c. Then you calculate. Okay, so a 0, b 0.5, c 1. So that's why you obtain 0.5. So the step is repeated. Okay, to repeat it, you just move right cell 1. Okay, and then that's why this one you have to eliminate. Okay, when you move, so this one no more. So this is left, this is center. You need one more here. Yeah. So now, okay, A, B, C. Calculate. A now is 0.5, B 1, C 0.5. Get 0.84. Okay, later on, you move it, okay, one column to right. This one no more. Yeah. Erase it. Okay, this one move. This become A, this become B. Okay, now here. You target here. From the target, left is the A, center is the B, right is the C. So calculate again. A is 1 here, B is 0.5, C is here 0. So you get 0.5 here. Okay, later on, you want to calculate level 2. Okay, you target here. When you target here, okay, from the targeted cell left bottom, this is A, center bottom, which is B, right bottom, which is C. So the O one, you may erase it, otherwise confused. So mean if you can recognize the pattern, so you no need to draw, you just keep, when you point to here, just use your finger, left, center, bottom, which is A, B, C value. And you calculate. A is 0.0099, B is 0.5, C is 0.84. Okay, just now the left boundary you just put into your table menu. Okay, table menu, of course you don't have t, will be x, exponent negative x, then you can get this value. Okay, later on. So you get 0.4760. Okay, and then to complete two more value here, move your molecule one column to right. Okay, so A. Okay, now this one solved. Now we move to here. So this will be A. B is a center bottom. C is a right bottom. And you calculate. So A now 0.5. B is 0.84. C 0.5. So 0.7312. Okay, lastly, this one. So A, B, C. Okay, lastly, this value. So this will be A, center bottom is a B, right bottom is a C. So calculate again. A 0.84, B 0.5, C 0.1. You get 0.1. Let me see. 0.84, 0.5. Oh, C wrong. 0.01. So 0.4760. Okay, just now the left boundary, you go to the table menu. I think number 9. Okay, table menu, you can only key in x, so the t, you change it to x. So x, shift, exponent, negative, alpha x, gx, let it 0. The t start from 0 up to 0.02. Okay, step side is 0.01. Then you get the value. Yeah, 0.0099. Okay, okay, t0, your u0. The second is 0.0099. The third, when t is 0.02, okay, the u is 0.0196. Okay, this one, because it's equal to t, so t 0.02, so t 0.01 also equal to 0.01, t0 is equal to 0. So this is using the calculator. Then of course you can easily perform it using Microsoft Excel. Discuss it. Okay, the second one. So here, coefficient for del 2u del x squared is a c squared. So c squared is 4. Okay, h given in the question is 0.5. K is 0.01. Then you can calculate the R is K times C squared divide H squared. Okay, so 1 minus 2R is 1 minus 2 times R here. So 0.68. Okay, and then you may, okay, if you want to draw molecule, this is 1. Or you copy it from here. Control C. Put it here. You will make it general, let it equal to here. This one, let it equal to this value. This one equal to, where is it? So this one, if it equal, okay, so mean next round, you just change your C squared H K R, automatically calculate 1 minus 2R, automatically calculate the molecule here, automatically calculate. And then now I got T up to 0.02. This is 0. So x from 0, 0.5 up to, I may center, select it, drag it up to 2. Okay, and the initial condition is here. Okay, this is initial condition. X 0 to 1, okay, is equal to x. So click x. 0 to 1. Yeah. Okay, when x from 1 to 2, okay, you can select it, is equal to 2 minus x. So they see this value, okay, for both function, both step function must be equivalent. Drag it. So this is the initial condition. Okay, put out the grids center. Okay, and the left and right boundary conditions. Put up here. Here. U0t, so mean when x0, okay, your function is t, click the t time, exponent, negative, okay, t, this one B14. Drag it, overlap. okay, the value. Okay, the left boundary and the initial condition at the this cell, they should overlap value. Okay, here right boundary u1 this is u2t typo u2t equal to t, so equal to here t, you copy it down. Okay, the last value also they should overlap. So you have only 6 inner value to be solved. Okay, and then you use this cell is actually r. Okay, here make sure you constant it, otherwise type in 0.16. So put it dollar front and the backs to constant it time 0 left, okay, bottom cell plus, okay, 1 minus 2r, make sure you constant it, multiply center bottom plus r here, make sure constant it, multiply right bottom cell. Just select, okay, and then select up. Okay, you see, okay, why you need to constant. If you're not constant, when you copy the next column, initially you use F3, you move to G3. G3 move to H3. H3 move to I3, where your R, 1 minus 2R, and R value all are shifted one column to the right, which is wrong. So you see the formula. Okay, you only constant R, 1 minus 2R, and R because they are constant. Okay, left bottom, center bottom, right bottom, don't constant. If you constant, later on you will always get the same value for U11. So you see, okay, just now your left bottom, okay, initially left bottom, okay, at the C, okay, initially formula, okay, you observe back, okay, the formula. Okay, okay, the left bottom is C, center bottom is D, right bottom is okay, E. So CDE. So when you copy it, become CDE become DEF. The formula will, when you copy it next column, okay. So initially, okay, CDE will move one column to right, become DEF. So when you copy it up, okay, when you copy it up, okay, initially, okay, also CDE, but it's a E16, you move up E15. So this is okay, the what we call relative column and relative, okay, row in Excel, which is okay, let you easily perform your numerical method quickly. Okay, this one is without round anything. If you want to round, then you round it, round round to 4. Okay, select, copy it up. Okay, and then this one you will see 1, 2, 3, 4, 5. Okay, if you want to perform using, okay, the spreadsheet menu, cause here exclude the, okay, T, the grids that we need is actually 1, 2, 3, 4, 5, 5 column. Then you may use the spreadsheet menu. Okay, but the spreadsheet menu, will turn it. The initial condition will put up the first row. I'll put first row. So mean, okay, firstly we put up the initial condition, the formula, okay, here. Do you want to discretize the x? Okay, we put out the x value. Let's say here 0. Okay, first row. Okay, first row I put up the x value 0.5, and then 1, 1.5, and then this is 2. Okay, if you use a spreadsheet menu, okay, first row is actually the discrete the x value. Okay, the t I cannot put because just enough for 5 column, 1, 2, 3, 4, 5 in spreadsheet menu. Okay, and then the row 2 is actually the initial condition, x 0 to 1. okay, it equal to the x value, so it's equal to 0. This one equal to 0.5, and then equal to 1. Okay, so when x from 1 to 2 equal to 2 minus x, so if x is 1, 2 minus 1 is 1, so it's overlap value. So when x is 1.5, 2 minus 1.5, you get this value is 0.5. Okay, and then when x is 2, your u is actually 2 minus 2 is 0. Okay, this one. So mean, okay, if the spreadsheet, the first row is the x, second row is the initial condition. Okay, mean, okay, spreadsheet, okay, I put cost from top to down. Will be okay, the first row x, second row is actually the initial condition. Later on, okay, then this row, okay, this cell, mean spreadsheet, okay, this will be in the spreadsheet. This is row 1, this is a row 2. So I got the 4 row result there. Okay, row 3, this value is t exponent negative t. But we don't have the t there. Never mind. So I put out the value t. T is now row 3. T is point. Okay, alpha equal, where is it? 0.05 shift exponent negative 0.05. Okay. Shift no, check back the formula. Number 4, number 2 formula. T is 0.01. So to edit the formula, options, number 3, okay, mean I want to calculate the left boundary condition, where is t is t is 0.01, so I key in wrongly. 0.01. No. Okay, and then I copied this never mind. The next one, this is alpha equal, because limitation I cannot key, I got not enough column to key in the t, so I cannot key in formula generally. So this cell t is 0.02 exponent negative 0.02. So you get, okay, here this value 0.0196, correct? Okay, and then go to calculate A, B, C, D, E. Okay, at here, this one is the right boundary condition. When the right boundary condition, because it's reverse, here equal to t is 0.01, then here 0.02. So mean here, okay, the spreadsheet in calculator, the first row is in the x, second row is your initial condition, and it's it's reversed, top and bottom upside down, because we start easy, we start from row 1, because it's not like in Microsoft Excel you can drag up. This one we fill in the x from first row initial conditions, second row, and then the t equal to 0.01 is the third row, t equal to 0.02 is a fourth row. So that's why it's 0, 0.01, 0.02. Column E is the right boundary condition. Column A is a left boundary condition. So you see inner also you have 1, 2, 3. Okay, 4, 5, 6, 6 cell to be solved. Okay, so now I'm going to key in the formula in the cell B3, like what you key in to get the first formula in Microsoft Excel. Okay, so I'm going to key in alpha equal, directly key in is 0.16, 0.16, and then left bottom, in the spreadsheet in the calculator, this cell will become the left top, which is a A2. Mean you flip it, now you target at here, left bottom now become the left top, which is A2. Alpha A2 plus 0.68, center top, because it's flip down, flip up. So B2 plus 0.16 ABC, so alpha C2. So you get here, in this one, 0.5 here. So this is a 0.5. Then, I'm going to copy the formula. So options, copy paste is number 2. Move to the right, right hand side equal to paste. So you get here 0.84. Point here, 0.5 here. Down, paste, which is 0.476 here, down, paste, left, paste. 0.476. Then AC. Then just, if you want to see what is this value, shift menu, number 4, number 2, value, and I get 0.0099. So if you use the spreadsheet menu in calculator, is upside down, because we fill in easy. We fill in the level 1 is actually the x 0.51, 1.5. How to make here 2, and then the row 2 is actually the initial condition. Row 3 is actually level 0.01. Row 4 is actually 0.02, and then what I key in the formula just now is at B2. B2. Let me see back the formula for number 2. Where the formula, shift menu down, number 4, show cell number 1. Why not show the value? Oh yeah, this one. B3. B2 is the initial condition, B3. B3 0.16. If you use the spreadsheet menu, provided the solution is only 5, maximum you can only 5 column. If more than that, cannot. Because it have only 5 column, provided 5 column. So the cell here, U11, that I'm going to solve, I put up into the cell B3. So B3, the left is actually A. Right is actually center is actually B, right is a C, but your target is at the bottom, and your initial mean the here left bottom, center bottom, right bottom in the spreadsheet menu in the in the calculator will become left top, center top, right top. That's why you key in the formula C3 at the B3, mean you key in the formula is actually at the cell CB. Sorry, we key in the formula at the cell actually B3 equal to 0.16. Left is actually A2 plus 0.68. This is a B2 plus 0.16 C2. Compared to here, this one, because okay, in okay, Excel you can exactly target at the top. So your left, okay, bottom, center bottom, right bottom. But in the spreadsheet menu, okay, we reverse it. The first level, okay, row 1 is actually X, row 2 is actually initial condition, so row 3. Row 3, okay, the first cell that we are going to solve is actually at the cell B3. So B3 equal to R, okay, instead of left bottom, this is the left top, center top, right top. So this is a okay, different okay, if you use okay, spreadsheet menu and spreadsheet menu in your calculator compared to the Microsoft Excel. Okay, unless okay, you know okay, exactly here you put up this way. You go to okay, if you want the same layout, then you already know the solution like here, then you just go to put up this at the row number 4. Then you can the same layout.